Hello everyone, welcome back to Science Simply, where complex doesn't have to mean complicated. Meet Priya. She's a delivery driver and she has one job: get a package from the warehouse to a customer's house 8 kilometers away. Sounds simple, but here's the thing. Depending on what question you ask about her journey, you'll need completely different types of numbers to answer it. And that difference, that's the entire foundation of physics. By the end of this video, you'll know exactly what scalars and vectors are, why the distinction matters, and more importantly, how to instantly tell which one a problem is asking for. Let's get into it. In physics, every measurable quantity falls into one of two categories. A scalar is a quantity that is fully described by just a number and a unit. That's it. No extra information required. A vector is a quantity that needs two pieces of information: a number, a unit, and a direction. Without the direction, it's incomplete. Here's the key question you should always ask yourself: would knowing the direction change anything? If yes, it's a vector. If no, it's a scalar. Let's go back to Priya and see this in action. Priya doesn't drive in a straight line. She takes winding roads through the city. By the time she parks outside the customer's house, her odometer has ticked up 15 kilometers. That's the total length of the path she traveled. That quantity is called distance, and it's a scalar. It doesn't matter which direction she drove at any point. The odometer just keeps adding 15 kilometers, and that's it. But now ask a different question. How far is the customer's house from the warehouse in a straight line? In other words, what's the shortest distance between the initial and final position of Priya? That's 8 kilometers due east. This is called displacement and it's a vector. It has a magnitude, 8 kilometers, and a direction, east. Both pieces of information are essential. 8 kilometers alone doesn't tell you where the destination is. Same journey, two different questions. Two completely different types of answers. Alright, so let's try this question. Priya later drives 6 kilometers north and 6 kilometers south, ending back at the same spot. This is important for later. Two questions, we have to find a distance and displacement. Before we answer the questions, let's just draw a diagram of her motion. So she first goes 6 kilometers up, so north basically, and then she goes 6 kilometers south, so down. Note that there's no horizontal motion. I'm just adding it for the sake of visualization. Actually, she just goes up and she just comes back down. Alright? So, first question, distance. So, first we have to find that distance is a scalar. We obviously know that. So, basically, we don't have to care about direction. So, first she goes 6 kilometers. I don't care about the direction. She just goes 6 kilometers. And she comes back down. Note that the direction is the opposite, but I don't care. Why? Because it's scalar, so I can just add it. 6 kilometers, 6 kilometers, 12 kilometers. Now, second is the displacement. Note that mine is arrow, but don't worry about the arrow right now. So first, the displacement. First, she goes up 6 kilometers, right? So it's positive 6 kilometers, because according to the sign convention, north is positive, south is negative. And if we're talking about west and east, well, east is positive and west is negative. Now don't worry about north, east, south, and west right now. We're gonna eventually lead to only the sign, and if the our object is moving like in a diagonal path like that, don't worry about that just yet. That is a little more advanced, and we'll come to that later. But for now, it's only going across one axis, the north-south axis or the y-axis. So if you refer to the normal coordinate plane, this is positive y, and if this is origin, this is negative y. So if at first we go 6 kilometers positive y, we also come back down 6 kilometers negative y, so minus 6 kilometers, and ultimately we get 0. This is very important. Why? Because this keyword ending back at the same spot, This is basically just instantly tells you that if the displacement is zero. Why? Because the the initial position and the final position is the same. The distance between them is zero. Why? Because it's the same thing. So displacement is zero. Now here's where it's interesting. While Priya is driving, her speedometer reads 60 kilometers per hour. That's her speed, a skill. It tells you how fast she is moving. No direction, no problem. But her navigation app is thinking about something different. Now, don't worry, your actual Google Maps won't tell you your velocity, but just for the sake of the example, it knows she's taking a roundabout route. The straight line gap between her and the destination is closing at only 32 kilometers per hour because she's curving around a one way system, not heading directly at the house. Alright? So that's the second quantity, 32 kilometers per hour towards the destination. That's your velocity. It's the same unit, right? But it's completely different value. Why? This is the 60 kilometers per hour, but note here the number is different and there's a direction as well. Alright. So speed tells you how fast, velocity tells you how fast and where, and that's the difference between them. Before Priya set off this morning, she checked the weather. Two pieces of information caught her eye: temperature, which is 25 degrees Celsius, and wind, 18 kilometers per hour northeast. Now, here's the question: why do we care about the direction of the wind, but we never say 25 degrees northward or 25 degrees southward? Because temperature doesn't have a direction. Heat just spreads in all directions equally. It's a scalar. There's no such thing as a heat pointing somewhere. 25 degrees Celsius is just 25 degrees Celsius. That's it. Wind is different. The direction the wind is coming from changes everything. Whether it's a headwind slowing her down or a crosswind that makes her cycle unstable. 18 kilometers per hour is alone is incomplete. 18 kilometers per hour northeast. That's the full picture. So if you draw the vector, it's 18 kilometers per hour, right? I'm just gonna write 18 kilometers per hour. But note that it's also in the east direction and the north direction, making the direction northeast. Alright? So this is an important point. Scalars aren't simpler or less important than vectors. They just describe quantities where direction is genuinely irrelevant. The distinction isn't about complexity, although the vectors are more complex. It's about what information the quantity actually carries. Here's the moment where this stops being just definitions and becomes actual physics. Priya makes two legs of a journey, 8 kilometers east and then 6 kilometers north. What's your total displacement from the start? If you treat displacement like a scalar and just add the numbers, 8 plus 6 equals 14, you're wrong. You lost the direction information and your answer is physically meaningless. I know that's harsh, but this mistake will cost you marks in exams, okay? Vectors don't add like scalars. You have to account for direction. In this case, we can use the Pythagoras theorem. Because the two legs are perpendicular, why? Because north is perpendicular to east. The actual displacement is 10 kilometers at a specific angle northeast. 14 versus 10, that's not a rounding error. It's a fundamentally wrong answer, and this will cause you to lose marks. And this is why the distinction matters. Not for the sake of definitions, but because if you treat a vector like a scalar, your calculation will be wrong every single time. So let's do this question. A student walks 3 kilometers east and then 4 kilometers north. What's the magnitude of the student's displacement? So as you can see, it walks 3 kilometers east. So 3 kilometers east, and then it travels 4 kilometers north. So let's say 4 kilometers north. So what is the displacement? Well, it's basically the shortest distance from the initial and final position. So this is the initial position, and this is the final position. This is the distance, right? It's the shortest possible distance. You know, I guess it's a straight line. So how do we calculate this line? I'm just gonna write S because that's a symbol of displacement. It isn't, it's a convention, but you'll see people writing all sorts of different symbols for displacement. But I said write S. So how do we find out the magnitude of the student's displacement? So as you can see, First asking us for the magnitude, right? So we're just gonna calculate the length, but for the sake of the question, we'll also tell the direction. So first we know this is east, this is north, and obviously the east and north are perpendicular to each other, and now we can see it's a right angle triangle. So by the Pythagorean theorem, we can say s squared equals 3 kilometers, count for units obviously, 3 kilometers square plus 4 kilometers square, and then we can take the root of both sides. This will become 9 plus 16, 25 kilometers square, and then since we take the root on the sides, we take it onto the root, and this is 5 kilometers. Now you don't need to do this. If you have the Pythagorean triplets memorized, you can also instantly get that this is 5, but just for the sake of calculating, we did it. And if you want the direction, it's north, it's east, it's northeast. I know, I'm a genius. All right. Alright, so let's bring it home. A scalar has a magnitude only: distance, speed, temperature, time, mass. A vector has magnitude and direction: displacement, velocity, force, acceleration. These are examples of vectors. The question to always ask: does direction change the answer? If yes, you're dealing with the vector. And the reason this matters isn't academic. Add vectors incorrectly, treat them like scalars, and your answer is wrong in a way that can't be fixed by better arithmetic. The error is in the setup, and that's why it's important to pay attention. Priya's journey gave us every example we needed. The same trip, the same numbers, but completely different answers depending on whether you ask a scalar question or a vector question. Alright, so in the next video, we're going to take vector addition seriously, and Priya's going to help us again, this time with a journey that can't be solved without it. If this clicked for you, subscribe. There's a full physics series building here. Each video connects directly to the last. Drop a comment below. Before watching this, did you know the difference between speed and velocity? I'm genuinely curious how many people learned them as the same thing. Alright, so see you in the next one. Peace.